Okay, so today's should be pretty short, just continuation of yesterday. That's why it's 26B. We're only doing one example today, but this example is very similar to what we did yesterday, the last thing we did yesterday, but it's a little bit more involved, I'll say. I don't know if it's any more difficult, same kind of thing, it's just a little bit more involved. So here we go. We're trying to find the maximum, that's what we're doing, that's why I called it that, the maximum and minimum values of this function. So it's f of xy. Come on, pen, help me out here. There you go. Is equal to x minus y plus 2. All right, and now they're going to give you some restrictions on your x's and y's. All right, so this is our main function that we're going to work with. And they're going to give you some restrictions. So here they are. We got 4 of them. So it's x plus 4y is less than or equal to 12. So what we're going to do is we're going to graph these 4 things that I'm putting down here. And here's another one, 3x minus 2y. Put it right here. 3x minus 2y greater than or equal to negative 6. Then I got x plus y greater than or equal to negative 2. And one more, 3x minus y is less than or equal to 10. Okay? All right. So here's what I want to do. I want to graph all these, and you're going to have a bunch of lines, 4 lines. You're going to have shading in there. You want to find out where all the shading comes together, okay? Where they basically intersect each other, all right? So let's do this. How am I going to graph this thing right here? Well, first of all, I got to do something before I graph it. What do I want to do to this? Yeah, slope-intercept form is probably the best way to do it, okay? I guess there's other ways you can do it. You could do the x and y intercepts, blah, blah, blah. But let's just do slope-intercept form. Kind of used to that. So 4y less than or equal, get rid of the x, put the x over here, plus 12. Divide everything by 4. Divide that by 4, by 4, by 4. And then y is less than. Now I divided by a positive, so I don't have to change the inequality, so I keep it less than. What's this going to be? Negative 1/4 x, and then plus 3. All right, so that's one thing that I'm going to graph. I'll put it in a little box so I remember. All right, keep everything organized. Girls watching? Let's do the same thing here. Subtract a 3x, so I got negative 2y is greater than or equal to negative 3x minus 6. Divide everything by a negative 2. Well, that should trigger something in you, right? Divide by a negative, so what should we do here? Change the direction of the inequality. So this will be positive 3 over 2x, and this will be plus 3. Put that in a box, and we're going to graph that. Seems like all I do every single math class is do this equation of the line stuff, because all 3 of my honors math classes are doing equation of the line. Some are getting it better than others, I'll tell you that much. My geometry class is struggling a little bit with it. So it's still working? Okay. Here we go. Subtract an x from both sides. So we'll just put it right here so it's all in one line. Greater than or equal to. Are you guys writing this down? Mia, I hear you talking above everybody else. I know you're whispering, but I still hear it. All right, so that's that one. We got one more to do. Should be writing these down. In fact, you could probably be a step ahead of me, right? Right? When I was working on this one, you probably already had it down, then start working on the next one. So I subtract a 3x, so negative y is less than or equal to negative 3x plus 10. Divide everything by a negative. If I divide by a negative, then I got to change the inequality, and so that's going to be a positive 3x minus 10. All right, so there's all the things I'm going to graph. Well, let's get a graph. Let's use this one right here, be nice. And I'll put those up here, give me some room. Well, I just finished grading a quiz in my geometry class. Some did pretty well. I got one kid got 100, then a couple of them got like 18, 19 out of 20. But then some of them didn't do so well, like pretty bad. Got like one or two right. I don't think anybody missed them all. Well, no, one kid, yeah. Well, I'm not even going to tell you who it is. Don't even ask. But one kid out of, what have we had, 3 or 4 quizzes so far, plus a test. I think he's only answered 2 right out of like 4 quizzes in one test. So, yeah. So, yes. Well, it's not 200, but anyway. Well, I did talk to his mom, and we talked about maybe putting him in CP, but I don't think she really wanted to. She was kind of like, well, let's just see how it goes. So anyway, that's about all I can do. But anyway, at this point, this is pretty. At this point, these things should be pretty common to you now, right? Yeah, solving for y and all that kind of thing. Yeah, but it probably wasn't always like that for you, all right? You might have struggled yourselves, but you probably had it in Algebra 1, you had it in Geometry, you had it in Algebra 2, so you guys have had it 3 years, you know, so, and that class has only had it, well, some of them had it last year, but a lot of them didn't have it, so sometimes it's the first time you see it, and it is a little confusing. I mean, I'm not mocking them. It's what? Intuitive? Yeah, I mean, well, once you've done it for a while, sure, it's intuitive, but if you've never seen it before, it's hard for you guys to think back when you first learn this stuff. But you probably struggled with it too at first. But you've done it so much. Anyway, all right, let's do this. Come on. Here we go. Let's graph this. So we'll just keep it all red. Is that all right? I was going to do all different colors, but we'll just do this. So positive 3, 1, 2, 3. Slope is negative 1/4. So we rise negative 1, 1, 2, 3, 4 right there. And there's our line. All these are or equal to, so no dotted. So it's going to look like this, and it's going to look like that. Yeah, it seems kind of elementary now, doesn't it? Yeah. But again, it probably was not that easy for you when you first did it. I don't know. Maybe it was. All right, here we go. Plus 3. Here another one intersects right here, and it's positive 3/2. So 1, 2, 3, 1, 2. And let's go down here as well. 1, 2, 3, 1, 2. All right, let's connect them. And yeah, it should be good right there. All right, so that's another one. By the way, on that first one we did, we're going to shade below it, correct? Yeah. And on this one, we're going to shade below it, or down in this direction. So far, all this stuff right here is being shaded. Now we got a greater than. So the y-intercept is negative 2. Negative 1 is the slope. Rise 1, right? Like this, like this. You can keep on going, put a bunch of dots in there if you wanted to. What's kind of nice, I like to put enough dots where I see that point of intersection. Because remember what we're going to do to find the maximum and minimum? We're going to find out where they intersect. All right, so that's an important point, so I put a dot right there. And then we just connect them like this. Now, where are we shading this one? That one we just drew. Above, right. So where is the shading so far? It's all in this area right here. It's not really a triangle. No, not in here. It's all the stuff in here so far. Correct? Because we're above this and we're below this, but below this. So that's everything inside of there. We got one more to do, another greater than. Mine is 10. I don't even think I have 10 on here. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10. So if I rise 3, I go 1, 2, 3, 1. Do you see that? So I don't really see my y-intercept because it's off the graph a little bit. But if I rise 3, I'm up to here, right? Because I'm 2 below. Make sense? All right. And then I'll just do a few more. 1, 2, 3, 1. See where it hits right there? Yeah. So really, this is not much. And I'll tell you what, let's do this. Let's do a few more. Let's see if it actually intersects there. So we go 1, 2, 3, 1, 1, 2, 3, 1. Yep, bang, right there. So that makes it nice. So I know, oops, I'm off my graphics tablet. All right, so there we go. And it's greater than this. So this line we just drew, where is greater than? Well, it's above it, but this is starting to get a little close to vertical, isn't it? So sometimes it's hard to tell. But yeah, this would be above it. So what's the shaded area? It's everything in here. Okay? Everybody got that? All right. So that's the graph. What are we trying to do? Find the shaded area. I'll do this in a different color so it pops a little bit. Let's go blue. So in order to find the maximum and minimum, what are we looking for? We're looking for the point of, now there's a lot of different, well, there's not a whole lot. There's a point of intersection here. Eventually, these would intersect, all right? These would not intersect. But where's our point of intersections? Here, 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 and here. Agreed? Yeah. So those are the points we're going to write down over here on the side. And then we're going to put them into our function. All right, we're going to put that x and y into our function. Then we're just going to look to see which one's the biggest number, which one's the smallest number, and where do they occur. There we go. All right, so let's write the order. I'll tell you what, let's write the function down again because it's off screen. Is it x minus y plus 2? Is that what it was? Yep. All right, so let's put our points. I don't know. Let's do this one first. Where is that? -2, 0. Agreed? All right, and this one is 0, what? 1, 2, 3. This one is 1, 2, 3, 4, 2. And this one is 1, 2, 1, 2, 3, 4. So that would be 2, -4. Everybody with me? Any questions so far? All right. So now, what are we doing with those points? Putting them into this function right here and finding out what they're going to equal. All right, let's put a -2, 0 in there. So -2 minus 0 is -2 plus 2 is what? 0, right? Yep. So that's 0. Put in 0, 3. So 0 for the x, 3 for the y. That means that's -3 plus 2 is -1. You can do that in your head, can't you? If you can't, you can write them down. It's fine. 4, 2. Let's put a 4 in for this. That's a 4 minus 2. 4 minus 2 is 2 plus 2 is 4.
Chairman, where'd you get that equation from?
That's what they gave you. They gave it to you. Yep, I wrote it at the top. See right there? Okay. And then one more. 2, -4. Put a 2 in for this. 2. Since we got a couple negatives, we'll write it out just to make sure we don't make a mistake. Minus -4, which is what? Plus 4, and then plus 2. So that's 6 plus 2 is 8. All right? So now, what are we looking for? We're looking for the smallest number, and we are looking for the largest number. So this would be the what? The minimum, and this would be the what? Maximum. Okay? So if you're going to write your answer down, the minimum, you want to find the value, the ordered pair, okay, where it's the minimum. So where is the minimum? The minimum is 0, 3. So we're not going to write the minimum as -1. We look to see the ordered pair that associates with the smallest value. All right, and then of course the maximum would be what? Be 8. And where is the maximum? It's at 2, -4. And that right there is your answer.
So what is the 1 and the 8 like represent?
The -1 and it just shows you which of these values gives you the smallest number. It's all it's doing, okay?
In like a example where you would use this graph, what is the smallest number? Like why do you need to know that?
We did this. Do you remember that? I don't know. It's probably, but this was a pretty good example we did last year. I don't know if they have it here or not. Do you remember that word problem where we talked about them selling and it had the weird words for like, I forget what it was. Yeah, it was like the snowboards. Remember that one? Okay, that's where you can use stuff like this. Okay, where you're trying to find how much of this and how much of this should you sell to get the maximum profit. Okay, and that's the kind of stuff that you're going to do. So I don't think they give you an example like that. I don't know, maybe they do. Did they give you an example after this one? This was example 3. Is there an example 4 on there?
No.
Okay. But in the Algebra 2 book, we did. Do you remember that? We did that big example, and that's what's going on here. So you could absolutely use this. I mean, this is absolutely used like in the business world, right? If you're selling things, if you have a store, you want to figure. Now, nowadays, you could probably just punch numbers in and a computer program will do it for you. But this is what's going on behind the scenes, right? This kind of thing. So it's very helpful to know, like, you know, to the maximum profit, you might want to sell 2 of these kind of snowboards. Well, I don't know if you'd have a -4. I don't know. This probably is not like a real life example maybe, but it's just showing you how to get it, all right? So that's the kind of thing that we did. We spent quite a bit of time on that example, I think. So I thought you might remember that one. All right? Yes. So what did I give you? I don't have my thing in front of me. Let me see. Didn't I make it A and a B? I did. So last night you're supposed to do 7 to 28, correct? No, looking at the wrong thing. I'm looking at Algebra 2. Hold on. Let me go to pre-calc. 9 to 15. No. Yeah, 9 to 15 was yesterday. Today is 17 to 22. All right. 17 to 22. And it's section 26B. All right. We can answer some questions on the homework if you want, on the yesterday's homework. But if you can do what we did right here, you should be able to do yesterday's homework, don't you think? All right, so I'll let you work on 17 to 22. Make it 2 sections, okay? So make it B, and then we'll collect that on Monday.